Okay, so in the last video, we were looking at the difference between two variables in the same sample. So in this video, we're going to start by looking at the idea of what happens if I'm interested in two samples taken at different times and how those percentages or those values have changed in that time. Oops, clicked on the wrong thing. So let's quickly get back to where I want to be. So here I've got a survey that was done in 2014 about which surveyed 600 residents in a city and asked about the installation of traffic lights at busy intersection, and they found 44% were in favour. They then did the same survey with a new sample of 500 residents in 2016 that found that now 52% were in favour. And the question is, can we say that the percentage in favour of the traffic lights has increased? So I've got my calculator here because I'm going to need to use that today because there's a number of different things I need to work out to be able to come to that conclusion. So the first thing I've got to do is I need to work out my margin of error in 2014 and my margin of error in 2016. So 2014 margin of error, well, my percentage is bigger than 30 but smaller than 70, so I'm okay. I can use my rule of thumb. So that's 1 divided by the square root of 600. I'm going to do all my calculations in once, so I'm just going to set up all my stuff first because it's in a separate window and that's a little bit annoying. So 2016 margin of error was 1 over the square root of 500. Okay, so get my calculator. 1 divided by the square root of 600 gives me that my decimal is 0.0408, wasn't it? Yep. Or 4.08%. I'm deliberately doing more decimal places than I need here because I'm going to round my answer in a little bit. I'm using the fact that the graphics calculator will let you go back using these arrow keys to the last calculation because I only wanted to change one digit. So that gives me that my margin of error for 500 is 0.0447. 0.0447, or as a percentage 4.47%. Right, so that's that bit done. I really wish I could work out how to get these panes off the side from being visible so that I could make this window slightly smaller and just have my calculator sat there. So I've got my two margin errors. Now the reason why I need my two margin errors separately is now I need to work out my average margin of error. Okay, so my average margin of error is going to be 4.08 plus 4.47 divided by 2, which is going to get me a value of 4.2 something, isn't it? 4.08 plus 4.47 divided by 2 is 4.275. Right. Now, when I'm working out between two different samples, if I was working out between two of the same sample, I would double my margin of error. But because I'm working out between two different samples, I don't double my margin of error. I multiply by 1.5. So my margin of error, my difference margin of error is going to be 1.5 times my average margin of error. So my difference margin of error is 1.5 times my average. Okay, so in this case, it's going to be 1.5 multiplied by 4.275, which is going to get me, so that times that by 1.5. Right, it gives me 6.4125, so that's going to be 6.41. So I knew at the end I was going to round my answer, so I left all my decimal points as I was going through, and then I rounded at the end. Right, so I've done all the major calculations bit. So now my difference between my proportions is going to be 40, sorry, it's not going to be 40, it's going to be 52 minus the 44, which is 8%. So therefore my confidence interval for my difference is going to be the 8% plus or minus the 6.41%. Quickly finish writing difference. So that's going to be 8 plus 6.41 is 14.41% is greater than, and 8 minus 6.41 is 1.59. So the true population difference is likely to be between those two values. And because 0 is not in the range of those two values, I can claim that there has been an increase in the percentage of support for these traffic lights. Okay, so I hope that all made sense. That's probably the hardest calculation you have to do in the standard. The rest from there is about the interpretation. So good luck with that, and until next time.